All right, welcome to our free GMAT prep hour for March 2025. I'm Dmitry, and today's lesson is going to be on math the hard way. And my thinking on this is partly that when I was playing this session, I often try to look at clever patterns to look for and cool tricks to do things faster or more easily. And for whatever reason, I wasn't feeling as clever. And some days we're not, right? And I wanted to talk about that in the sense of the pressure we sometimes feel on the GMAT to always have a really fast way to do things, always have a really easy way, something that doesn't require a whole lot of time. But also just that feeling we might have that to get a hard problem right, we have to be super smart. We have to think of something that other people don't think of. And that's only one type of difficulty that the GMAT presents. Sometimes they can just give you something that's just a lot to do. Now they're not going to give you, some long, 20-digit long division problem or something like that to do by hand. But sometimes they give you questions that just involve a lot of steps. And because there's a lot of steps, there are a lot of places where we can misinterpret, misorganize, miscalculate, something can go wrong. And so we want to just talk a little bit about how to stay accurate, how to stay organized when you're dealing with a more complicated problem. On your DI section, sometimes that means you're getting out your calculator. Sometimes you're not though, and on your quant section, of course, you don't have a calculator, and so it's really a matter of how do I make sure I know what the question's asking for, make sure I'm providing what they're asking for, and how do I organize the steps as I go when there aren't a lot of tricks. Now, maybe you'll look at some of these and you'll find a cute trick. Oh, look, there is a way to narrow this down, or I have an idea of how to guess, or I know the answer can't be even, or something like that. And cool, if you see those things, fantastic. But I want to focus on more just how to do it out, how to do the work. So we'll do a bunch of quant-based problems. Some of them will be from the data insight section, so we can have a multi-part question. But they'll all just be like getting your quant moves down. So let me start you with something that comes for data insights, where you just gotta read the table and see, or read the chart and see what we got. So let me give you some time to do this. I'll put a poll and you can just poll in your answer when you have it. Okay, so give this a try. Take about 2 minutes, a little more if you need it. We'll go from there. Okay, let's talk about this one. I don't know why I put a poll on this because it has two parts, so you'd only be able to poll one part of it. Um, but how is this going? Were you able to make any progress on it? And welcome, BJ. I know you might. I think you joined us part through, so you might not have had a full chance to look at this, but welcome. Um, let's see what we can do. We want to organize this information, and we want to just do some calculation. And the good news is when you see one like this that has a uh, chart of some kind, right? Anytime that's from the data insight section. So charts, tables, two-part questions, data sufficiency with two statements, anything that's not a regular math question means it's in your data insight section and you'd have a calculator, right? Normally you'll know when you're practicing whether it's from data insights because you'll have been, working on a particular drill or set or you'll be in a particular part of a practice test. But in class, I'll kind of go back and forth a bit. So this is one where we would have a calculator available, that we may or may not decide that we need it. So we just want to read this chart. This is breaking down number of billionaires in the world by percentage as of 2007. Maybe that's shifted a bit. Lots of billionaire moves going on out there. So at the time there were 946 billionaires, and we want to compare the U.S. to Russia, the U.K., and Germany combined. So this is certainly something where I could do some kind of approximation. For instance, I know US has less than half the total billionaires. So the total number of billionaires that there are is going to be a little less than half of this number, this 946. So, maybe US has somewhere around 450 billionaires. And if the other countries have some, then our answer needs to be well below that. It's probably not E. Um, but we can organize this a bit more and do it out fully. So I could say, all right, so US uh, is 44%. And then if I add up the UK and Russia and Germany together, what is that, 12, 15%? I can approximate that that's 30%, but since I'm working with a calculator, I might not bother to approximate. I might simply just, again, just do it out and say, all right, well then if I subtract those, I'm going to have a precise difference of 29%. If I'm approximating, I could say, all right, well, that's around a third before I even do it. And around a third of 946 is going to be 300 something. B and C look really good. A, D, and E less. D is, it's high 300s, but I think we want under a third of 946, so under 315. That's making B look really good. But sometimes I want to do these things out fully when I don't feel great about my estimates. And the closer together the answers are, the less I want to estimate, right? If the answers look like 274, 280, 285, 290, right? I might be able to narrow down because maybe I know the answer has to be more than this and less than this, and maybe only one exactly fits that. Um, if I know the answer, for instance, has to be under 300, then even an answer of 300 is going to be wrong. And so even in case of the answers are close together, I often have this ability to narrow down a bit. But sometimes when the answers are close enough, I just want to see a precise answer. So then I can just take 29% of 946 on my calculator. And here's one where if you're practicing, not everyone likes to have their phone out when they're working. But I use a simple like desktop calculator. I'm on Windows, but I think Mac has the same thing. You just pull up a calculator with the simplest functions. I don't normally use the simplest functions. I do 0.29 times 946. I get a kind of weird answer of 274.34. But okay, 274. There's not like a third of a person. So I want that number, and that confirms what I kind of already know. So can I do a bit of estimation here? Sure, once I've done that adding up and subtracting, but it's partly just a matter of really organizing and getting on my paper and saying, I want to compare this to this. Okay. For the second part, it says, and when you get this, by the way, it's all or nothing, right? Unfortunately. So if I didn't feel great about one of these parts, I might want to spend a ton of time on the other because it's all considered one question for the purpose of the test. No partial credit. So here it says if the portion labeled other represented 21 countries with equal numbers of billionaires, then each of them would have approximately how many billionaires? So I can get a really rough sense of this. I can estimate a little bit and say, okay, so I know that the other equals 26%. And so if this were 21 countries, if I divide that into 21 pieces, now here's one where I might approximate a little bit. I might say, okay, so each is a bit over 1%. 1% of 946 is 9.46. So it's going to be somewhere near there. B is looking really good. If I want to do it more precisely, I totally can though, because I could say on my calculator, what's 0.26 divided by 21? And again, I can just pull that up and get a precise answer. It doesn't take super long to do. And I get like 0.01238, something like that. And then I just say, okay, what's that percent of 946? And I get like 11.7. So the only number that's close is 12. So there is some approximation I can do. I can get an idea. Um, I might even have just taken a quarter of the overall. I could say, hey, a quarter of the overall is going to be like, I don't know, two something. A quarter of 1,000 would be 250. Quarter of 900, it's like a little lower, like 220. Maybe it's like 230 divided by 21. Hey, that's somewhere around 10 per country. I could get that estimate. But sometimes I just crank it on my calculator, and it's just a reminder that you can do that kind of stuff, even on a problem that has a few twists and turns. We could do it. Okay. Questions or thoughts on this? Okay. Let me give you something different. This is a regular multiple choice, just single. So this one I will have you pull in. Um, and so we'll check in after 2 minutes on this one. Since this is part of your regular quant section, it would expect to take 2 minutes on something like this. It's obviously a little bit ugly. I mean, you might find that it takes you more than 2 minutes. And then we look at, how do I do it faster while still, again, today is not about shortcuts. We'll just talk about doing out the steps, although we might still have to come up with a few cute ideas to get there. And so there's still a bit of when you do things out algebraically, there's still a matter of like, well, how do I choose my next step? It's not always as simple as if you were doing, say, long division where there's a clear process. Okay, let's take a couple minutes to try this. Okay, so this one's again a little tough. So if you don't feel like you are great on an answer yet, go ahead and select one anyway, just to get in that habit. So whether you're here live right now or you're watching this as a recording, commit to an answer. So you guys are here, pull something in just to have that. And if you're watching it as a recording, write something down. Because we can get better at guessing. Not always that because we have some clever idea, like I said, or because we can approximate, but also just because we get more comfortable making ourselves do it. And knowing that that time is coming sometimes changes how we allocate our time. When I know I have to guess, when I don't have the option of saying, wait, give me more time, when I know I have to answer within 2 minutes, then it changes how I think about that time usage and how I organize myself and what steps I take. And trust me, that's a big part of this. So go ahead and choose an answer for the poll. If the poll isn't working for you, just put it into the chat. Okay. So what can we do here? We got a big mess on our hands, a whole lot of material. You might identify this as having to do with quadratic equations. Um, and there's some patterns we can recognize here. Did anyone recognize a pattern? Anyone notice something that popped out as like, this is a move I can do, or this is like a little trick they're pulling? Anything that jumped out at you? And again, I'm not always feeling really on top of those things. I don't always feel like I know. Um, when in doubt, when I have a couple of equations with a couple of variables, a really common move is to combine those equations in some way, whether by stacking or substitution, right? Um, but here, I can't stack. Stacking is when I have something like, we also call it elimination. When I have something like, hey, A plus B is 7 and A minus B equals 1. And if I combine those equations, the B's cancel and I get 2B is 8. So A is 4 and B is 3. And I can solve that way. And that's beautiful when you can do it. In fact, that's commonly enough a strategy we have on the GMAT that I usually tell people to make that your plan A for simultaneous equations. The other common move that we have is substitution, where we isolate one variable and replace it in the other equation. But I think even before I do much with this, I can see that's not going to get me anywhere. Because if I try to isolate, let's say I try to isolate y, 3y equals 9 minus 4x. Y equals 9 minus 4x over 3. So first off, that doesn't look very fun to work with, just for starters. But now what am I going to have to do with it? When I put it into this other equation, I'm going to have to square that. Okay, 9 minus 4x times 9 minus 4x. And wait. Then I'm going to have to square that because I'm getting to the fourth power. And if you've got any experience squaring or raising things to powers that have addition or subtraction in them, it starts expanding and really, they're predictable in some ways. There's a whole binomial theorem and all that, but it's more than I want to do on a GMAT problem for sure. It's too much. So I'm not going to substitute. So part of what I'm doing when I'm kind of doing things not with a shortcut is saying, okay, if I'm going to do this out, I still have to be practical. I still have to look at something I can do. So what can I do? VJ is saying there is something to notice, and this is something where I think with training you want to see this. Is that this is a special product. And I'm not going to get into all the ideas of quadratics today, because if some of you have studied those, some of you haven't. But this is a common pattern. And the common pattern we see over and over again is a pattern of a squared minus b squared. When you have two things that are perfect squares. Now, I don't have an a or a b, I don't have a second power, but I have something squared. And that's going to equal to the sum of those things times the difference. And so in this case, what am I squaring? 16x to the fourth is a square of 4x squared. So this is like 4x squared squared. And this is 9y squared squared. And you might think, hey, I thought we didn't have to be super clever today. This takes a little bit of insight for sure, but it doesn't require you to be so much of like a bizarre math genius as to just be someone who's done this a lot of times and see it, right? When I see this on the top, this jumps out at me, not because I'm so great, but because I've done a lot of problems that have this exact same pattern in them, and I just recognize it. Okay, so that means I can rewrite this a little bit and then look for other connections. So I can rewrite the top of this as 4x squared plus 9y squared times 4y squared, sorry, 4x squared minus 9y squared. That's what the top will look like. Put in my squareds. Um, that's what the green part is. And one thing I'll do to save myself some time is rather than write the entire equation, so all this divided by 2x plus 3y equals 12x squared plus 27y squared, I want to be protective of my time. Just like it takes me a moment to write it out in Zoom while you're watching me, and so I'm self-conscious. I don't want to waste your time. It also takes a moment when I'm writing it on a paper to get all that down, and then am I going to rewrite it? And what I sometimes find, in fact, when I was doing this exact problem to prep for this workshop, I did this. I repeated several times. I end up dropping a digit. So at one point, I left a coefficient off one of my terms, and it went, oh, right. And so I'm trying to control for that as much as possible. I'm planning in advance to be human and make mistakes and say, how do I minimize the damage from those? Okay. So before I read the whole equation, I might say, hey, well, what can I do with this? Can I rewrite anything from this? Because that still doesn't look like anything on the right. It looks a little bit like the right-hand side where I've got an x squared and a y squared. Oh, and that's interesting. Okay, so I have different coefficients, but do you see a connection between the left-hand side and the right-hand side? Before I keep going, I might do that. So I could write the rest of this equation down just so we can see it. So if I do keep going, I'll have 12x squared plus 27y squared. And that's getting divided by 2x plus 3y. So, okay, now I am writing it out because I might recognize that, hey, that right-hand side is triple of one of my terms on the left. But if I recognize that, I might not write it this way. I might instead write it like this. I've got 4x squared and 9y squared getting multiplied by 3. So I might instead write this down. I made a mess of it. I write it like that. Okay, and if I see that, then this whole thing cancels with that whole thing. Now, what about the top? Is there anything I can do between this top and bottom? Well, this top is also a special product, right? It's the same kind of thing. It's a squared minus b squared. So I can rewrite the top as 2x plus 3y and 2x minus 3y. And this, if nothing else, take this as an ad for these quadratic templates. These are really valuable to memorize. And so you want to just have those down so you kind of recognize them in your sleep. Like that. So what I end up with is these canceling. And I just have 2x minus 3y is 3. The reason I was going on about I might not write all this is another possibility I could have done is before I rewrote the right-hand side and the bottom, I might have just said, hey, 4x squared plus 9y squared and 4x squared minus 9y squared can be rewritten where this 4xy times 9, I can't talk, minus 9y squared turns into these two pieces. And I might have rewritten that and canceled this before I wrote the other side. And that was another option that I had. All right, so at this point, I have an equation 2x minus 3y is 3. And I have another equation 4x plus 3y is 9. Now I can do my stacking. So I have this equation. And I have this equation. And I add those equations together, I'm able to find x. When I bugged you for an answer, I did see some of you giving me that answer. So if you got all that, even if it took you a little longer, then congrats, that's good. If you guessed, hey, that's a thing too, like as we guessed correctly. And there's incentive to guess on this test for sure. In some cases, it's more important, I always stress, to keep moving and be on time than to force yourself to the right answer. Anytime you have to choose between being right and on being on time, you want to choose being on time. But if we can also be right, obviously that's ideal. Um, so if this problem feels like too much for you to do in 2 minutes, how do you fix that? Do you come up with a cool trick? Maybe, but they're not really obvious ones here. And the answers are really close together. One, one and a half, two, three, four. So it's not like you're likely to approximate. And so one thing I'm often looking for is, what are some indicators that I can use a trick? Are the answers really different from each other? Do the answers have variables and I could pick numbers for those variables? Are the answers fractions or percent of some whole and I can make up that whole? Um, is there some other property I can use to see, like maybe some of the answers are like maybe all the answers are fractions and some of them are more than one and some are less than one. And so I want to say, do I know if the top is bigger than the bottom? Is there some other limiting factor? Here, I think it's a lot harder to get a feel from all these exponents what x is. Oh, x is around 2. Even if I knew that, would I know if it was 1, 1.5? Right? Might be hard. So sometimes I just need to do it out. So what do I need to have that? Um, so first, I want to recognize my difference of squares, right? That even when the powers are higher. So in this case, we had powers of 4, but it was still a difference of squares. It's still a pattern that we can recognize, right? So that splitting up that 16x to the fourth and 81y to the fourth down to smaller powers. The other is look for chances to factor out complex terms uh, and cancel them, right? So the stuff we did with the marking out in pink, right? First, I was able to cancel out the 4x squared plus 9y squared on both sides. I factored two different ways. I factored the left one way, I factored the right another way. I didn't know in advance when I started factoring that I was going to specifically cancel that term. It wasn't like my master plan. Maybe it was now because I'm teaching the workshop, right? But when I was solving this, it was not my master plan. I just started breaking stuff down, see what I could see. Um, but those are a really important thing to be able to do. And then after that, I broke that 4x squared minus 9y squared down further, and there was another complex term that canceled out. And then, if you have simple linear equations, no exponents, make stacking, also known as elimination, your plan A. And that's where we just stack these on top of each other, especially if you have something like here where the coefficients cancel each other out. I have a minus 3y and a plus 3y. Those cancel each other out and I instantly get x. Even if they're asking me for y, I might be tempted to just solve x really quick just because it was so fast to do and then go to find y. But I could also just multiply the top equation by 2, or by -2, I should say, and then the x's would cancel and I could find y directly if that's what I wanted. Okay. Questions or thoughts on this? All right, let me keep you working. Aim to answer this within 2 minutes, whatever you have to do, so even if it's a bit of a guess. But again, here's one where we might not feel great about approximation since the answers are so close together. So something to play with as you try this out. Here we go. Okay, let's have those answers. So even if it's a guess, get in that habit. Sometimes when we got some partial work, we have an idea from there of maybe where we can narrow down. And that can be something to look at too as you review a problem. Is there any point midway through, if I didn't have an initial idea about what the answer should look like, when I was, say, a minute in, did I have any more idea than before? Or was it the kind of thing where I didn't have any idea until the very end, which, can happen. Um, all right. So pull it in whatever you've got and let's see what we can do. Um, so in general, when we have a ratio, the most common way people do that is with colons. And I'm not a big fan of the colons, except for like maybe heading a table, because they don't look very mathy, right? And I'm not talking about look as in like, is it stylish? I just mean that I can't really easily do, if I say that something like books to clothes to electronics is 8 to 5 to 3, I can't do a lot of math with that. I prefer fraction marks, but even then, fraction marks, if I said books divided by clothes divided by electronics is 8 divided by 5 divided by 3, that could get really confusing. What does that mean, right? Am I flipping over? What am I flipping over? What? I don't know what that means. So what I might do instead, that we talk a lot about a lot with ratios, is instead of just using the straight numbers, use a multiplier to say that, hey, I don't know how many pounds of material he has, but there's some multiplier. Like maybe he has 8 pounds of uh, books, in which case he has 5 pounds of clothes, 3 pounds of electronics, or maybe he has, say, 24 pounds of books and 15 pounds of clothes and 9 pounds of electronics. So maybe the multiplier is 3. So what I will do is set up a little X and maybe put a table here where I'm saying books to clothes to electronics is in a ratio of 8x to 5x to 3x. And the idea of this is rather than having three separate variables, B equals books and C equals clothes, I'm saying, hey, there are three quantities that are each represented by the same unknown that are just getting multiplied by different coefficients, right? So if X is 1 pound, then he has 3 pounds of one, 5 of one, 8 of the other. If it's two, then 6, 10, 16, etc. So then a really common problem when we have like a longer problem or something with multiple steps is that we try to do everything at once. Someone will try to remove 4 pounds of clothing and also double the ratio. I might just have to think about it one step at a time, right? So I'm saying then that he's removing 4 pounds of clothing from his suitcase. So I could even have like a before and after. So he still, whatever X is, he still has 8x pounds of books. He still has 3x pounds of electronics, but now he's removed 4 pounds of clothing from his suitcase. Um, and so he has 5x minus 4. Someone who's approximating might use that as evidence. Hey, that means that the number of clothes he had must have been more than 4 pounds. And I might try to use that to narrow down what I have. It doesn't help me a lot here. So this would be 5x minus 4. Let me put that on one line. So then what do I do with this part about doubling? It says that when we do this, this doubles the ratio of books to clothes. Um, Now, a tempting thing to say, and it's what I almost did when I was originally solving this, is to say, oh, so then therefore 8x is double of 5x minus 4. That books is twice clothes. But they didn't say causing him to have double the ratio of books to clothes. So we have to watch what they mean by each line. It's saying doubling the ratio. So the ratio has doubled. So if we look at what the ratio was, the old ratio of books to clothes is 8 to 5. So the new ratio is double. What's it going to have to be? If you double it 8 to 5 ratio, it's got to be a 16 to 5 ratio. So now I can apply that to the pieces in the chart, but I'm not trying to do it all at once. I'm not trying to say double something in the chart. Instead, let me just do exactly what they said. Hey, all that happened is he took clothing out. Nothing else changed, right? It's that thing we do when we're trying to get under the luggage requirements on a flight, right? And I'll take some of my clothes and put them in my carry-on bag. I'll wear two jackets, right? Whatever I have to do so I don't have to pay that extra fee, right? So okay, so the books are staying as they are, the electronics are staying as they are, the clothing are going down by 4, but the new ratio is 16:5. So I can just say, all right, so the ratio of books to clothes is 16:5. Let me organize that. And now I can just pull, just as if I were doing an Excel spreadsheet, I can pull from the chart to fill in what those values are. So what's in a ratio of 16:5? The new number of books, which hasn't changed, to the new number of clothes, which has. So I'll have 8x over 5x minus 4 equals 16 over 5. Notice I can't cancel the x's because I've got two terms in my denominator, so I can't do this. But I can cross multiply, meaning I multiply this up here and that up there. So I'd get 40x equals 16 times 5 is 80x. And then 4 times 60 is 64. A little bit messy, but I can do it. Okay. All right. Now I get a funny number. Well, who said X was a integer? And I'm glad I didn't try to guess an integer. Like, hey, there's one, there's 8 pounds. There's uh, 16 pounds or whatever. It's going to be a funny number. And so here again, I might just do it on my calculator. But unfortunately, this is a regular quant question. I have no calculator. Okay, I can simplify this. I can say X is 64 over 40, which is, okay, take a 4 out of there. 16 tenths is 1.6. So now what do they want? Always check, always check. So often people tell me, I did all the work correctly, Dmitry. I'm looking on paper and I have everything right, and then I marked the wrong thing. Sometimes that means they answer the wrong question. Sometimes that means they answer the right question and they had the right answer on their paper, and then they just click the wrong option. It is surprisingly common. So check these things, check them, check them, check them. Right. So then I'll say, all right, what do I want? I want 3x because I want to know how many electronics I have. It could be either of the electronics boxes since they're the same. So I'm going to say 3 times 1.6, right? Which is 4.8. So that's roughly 5. So it's a lot going on, but again, we can do a lot of this thinking in terms of organization. So use that unknown multiplier to turn your ratios into numbers that you can manipulate. Before and after chart, really handy tool. You might be amazed how often you can make a problem easier just by saying, what do we have before? What do we have after? It's a percent change problem. It's a profit problem. It's a rate and work problem with multiple stages. Ratio problems are really common for this. Just what are the levels of my chart? Um, and then watching the specific information they give me at the ratio, and then using that information to fill in data from the chart. And don't try to do it all at once. Don't try to double something while also subtracting 4. First, just do what they said. The 4 columns of clothing were taken away. Then I say, hey, that represents a doubling of the original ratio. So instead of 8:5, I have 16:5, and then I fill those values in and solve. And then just always at the end, check to make sure you're answering what they want. So it's a lot of pieces of organization. But the more I can get in the habit of making these measures that catch my errors, the more I can know I'm going to get it right because I mess up a lot, right? You can see me do it, and you can see me stop and go, wait, and oh, hold on, and pause. And when someone's in my class long enough, they see me just be wrong and miscalculate or do something wrong to the algebra, and yet I can go take a test and miss very few to no questions sometimes, um, by having a process that's reliable, that's built on a fair amount of memorization of patterns that I've seen before. And I don't always have to feel super clever. Okay. Let's try another one dealing with ratios. This one has to do with cases. So it's going to ask you about these three possible cases. And when they say what could be, in theory, there's like 8 possible answers. One yes, no, 2 yes, no, 3 yes, no. But when they ask it in quant section rather than in DI, they won't have you check all the ones that apply. They'll have you choose a combo. And so sometimes there's a bit of a shortcut. Um, for instance, if I know that, let's say, two works, then I know it's either B or E, right? Um, if I know that one doesn't work, that's not as much of a shortcut because it could be two, three, or two and three. So it might affect where I test first, things like that. But basically, I just have to say which of these could be, which of these cannot be based on this ratio. So take a little time to try this out. Hold it. Okay, let's have those answers. Whatever you got. It's a guess. It's a guess. And certainly another aspect to these, hard work questions is if I don't feel like I know what that hard work is, and if I don't have a clever workaround or approximation or something like that, sometimes I just have to let the problem go. And that's okay too. Right. I put a guess in and I keep moving. And that's a big part of this test, especially if you're not maxing the test out. If you're getting it perfect in your perfect score, hey, congrats. Although I don't know why you're hanging out in my workshop at this point. But for the rest of us who, aren't there yet, or, maybe not need, maybe don't even need to get there, um, it's important to be really good at choosing your battles and letting things go. Okay. So they're asking what the ratio could be. Now, here again, I could do an X thing, 6x, 10x, 15x. Um, and the idea is that whatever whatever number I have either like because and notice they're not talking about weight or volume, they're just saying number. Pecans, cashews, and almonds, and a ratio of this. And some of the nuts are removed. What could be the ratio of pecans to cashews to almonds? So if they don't say anything otherwise, they're talking about actually counting the items. And 6 and 10 have some factors in common, and 6 and 15 have some factors in common, and 10 and 15 has some factors in common, but there's none that they all have in common, right? 6 is 2 times 3, and 10 is 2 times 5, and 15 is 3 times 5. So I can't simplify this ratio any further, which means that there are at least 6 pecans, at least 10 cashews, and at least 15 almonds. And so you could say that in a ratio of that, they can't be simplified any further, that those are the minimum numbers. Um, but then I could take some out. So what I might think about, just for starters, is what if I completely eliminated one of the types? They didn't give me that, right? They didn't give me a zero. But I could basically just say, all right, so if I've got pecans to cashews to almonds in a ratio of 6 to 10 to 15, or let me, instead of doing it that way, I might just do, what if I just said, hey, I could have some number to 10 to 15. And so in other words, the pecan number could change, or the cashew number could change, or the almond number could change, but only one. Right? They said I'm taking out one thing. So what I might think about then is, okay, so let's say I took out a whole bunch of the pecans, the first type, the 6. The others would be in a ratio that stays the same, would be 10 to 15. And that's a ratio I could simplify, right? So if I ignore the pecans, because those are changing anyway, I'm taking some away, and I look at the cashews and almonds, they're in a ratio of 10 to 15. What does that simplify down to? Those two have a common factor. I can divide them both by 5 and say, hey, this would have to be in a ratio of something to 2 to 3. So if I took away some pecans, I could get down to this. Okay? Because whatever this number is, I don't know if it's an integer or not, right? Maybe it is, but I'm pulling something out of these. I'm dividing these both by 5. So for instance, let's say if I went from 6 to 5, I could divide all these numbers by 5 and get 1 to 2 to 3. Oh, look, I can get choice 1. So I can get that. Working my answer choices, I'd say, okay, then it's either 1 or 1 and 3. What's fun about that is, because I know 1 is workable, I don't have to test 2. I know it's not going to happen. But if I did try to test it, I could narrow this down, but whether they have in common, they have a 3. So I could say, hey, this is 2 to something to 5. And there's an answer that looks like that. Similarly with the third one, these have a 2 in common. So I could simplify this down to 3 to 5. But there isn't an answer that looks like that. So my answer is just 1 only. So the idea with this in terms of hard work, sure, I had to be a little thoughtful about what to do. Hey, just turn the one that I'm removing down to a blank because I don't know how many I'm taking out. They just said some. It's too vague. And then I had to simplify. So that took some, creativity, you might say. Um, but it's also organizing cases and saying, hey, what if I have this? What if I have that? What if I have that? I have these different possibilities, and there are a lot of problems that end up getting done that way, where I'm testing a few cases that they've set up, and I can test all of them. It's different from when I say, hey, what if X is 4? What if X is 9? Or what if X is 23? It's one where I say, hey, one of 3 things is happening. I'm reducing the number of pecans. Okay, then what do I know about the other 2? I'm reducing the number of cashews. Okay, then what do I know about the other 2? I'm reducing the number of almonds. What do I know about the other 2? And then I can narrow it down in that way. Okay. Let's try one more. So we'll go back to data insights. So you do have a calculator for this. You might need it. Um, for this one, since we have 2 answers, uh, you can't pull it in, but you can chat it into me. So just give me your 2 answers in the chat. Your one will be the percent profit, percent decrease will be the other. I strongly recommend that you set up a table for this, and we'll look at how to do that afterwards. But try that out now. Even if you don't feel like it goes that well, you'll learn much more from it if you try it even unsuccessfully than if you wait for me to tell you. So give it a shot, and then in a couple of minutes we'll try it out and see how the table works. Okay, so a lot going on. Let's see what we got. So this is a good time to commit to a guess, but go ahead and put what you have. So let's organize this. Um, we are going to have two different years, 2010 and 2011. And then we need to look at what kind of information we have for each of those 2 years. So we have profit, fourth quarter profit, and we're going to have some number of shares, and that's going to equal profit per share. Okay. And so then we can think about how we can calculate some things with those numbers. So let's fill in what we have. So in 2010, we had 1.24 billion profit. In 2011, we had 1.38 billion. And they do talk about a percent increase in profit, so I can double check to make sure that makes sense. Hey, profits are up. They don't tell me the number of shares. They're going to ask me about that. They do tell me profit per share. So I know the profit per share in 2010 was $1.16, and the profit per share in 2011 was $1.33. Okay. So what do? I calculate that difference. I'm not going to put billions on my calculator, so I'll just leave the answer in billions. I'll say 1.24 divided by 1.16 just on my calculator is 1 point, it's some funky number, 1.0689, so I'll just call it 1.069 billion. And when I look at the 2011 figure, same thing, 1.38 divided by 133, I get 1.0375, so I'll call it 1.038 billion shares. So now what are they asking for? They're wanting it for the percent increase in profit and the percent decrease in shares. The formula for percent change is always difference over original times 100, although we don't always need to think about the times 100 if we can see what the digits are. So for our percent increase profit, I'm just going to find the difference between those two. 1.38 minus 1.24 is 0.14 billion, or just I'll just say 0.14. Over the original profit, the 2010 profit, 1.24. I can divide that. I can multiply that by 100 if I want. But again, if I do that on my calculator, I can see that it's going to be a little over 10%. 10% would be what, 0.124. So I might already have an idea of what the answer is. But if I do 0.14 divided by 1.24, I get 11.29, or I should say 0.1129 times 100 equals 11.29%. Okay, so our change in profit is 11%. Then decrease in shares, same idea. We're going to have a change in shares of point, really small, right? 0.031, but it's in billions. But since it's all in billions, again, I can just leave those units off over the original. The original is whatever I'm comparing to. I'm comparing to the start. So then I would just divide 0.031 divided by 1.069 and I get 2.899, so basically 2.9%. So there's a 3% roughly change. Okay, so I hope that even if some of these were fairly challenging today, um, the idea was that sometimes we can just organize it and run it out. And when you look back at a problem like this, you have to think about, okay, if it was tough, was it a knowledge gap? Did I not know my quadratic patterns? Did I not recognize how to calculate percent change? Was it just a speed and efficiency gap? Like, hey, I know how to do these things, but they take me some time, right? It's like if you're not a great cook, but you know how, maybe you can make dinner, but it just takes you longer than someone who cooks all the time. Maybe you know how to, change the oil in your car, but it's a little unwieldy and you just need to work for that fluency, right? Um, or is it a matter of I totally understand it. I know how to do it, but I make little errors, in which case, how can I organize better? How can I set up? How can I maybe create more structure on the paper? I don't want to write more than necessary, but maybe I can take some ideas from how we laid stuff out today to be more accurate on these. Okay. If you wanted, you can even add columns or rows to the chart to show totals or changes or things like that, right? So I could have, for instance, change of the third row under 2011 to show the difference over the original, or I could even just show the differences, right? I could say 2010, 2011, and then difference 0.14 for the first one, 0.031 for the second one. One difference is up, one difference is down, but they're both differences. And since the one's expressed as an increase, one's as a decrease, we don't have to worry about sign. There's either a negative or anything like that. So just organizing it. Okay. Well, hope that was helpful and hope everyone does well on their journey to the GMAT stars here. Feel free to check out any of our other resources. You can check out session one of any of our classes for free. Try that out. You can take our on-demand course and try that out. And you can also just find a lot of these other workshops on YouTube. So best of luck to everybody. Have a lovely night and good luck.